The summer of 1943 came to Detroit with the same heat it always did. Thick, industrial, pressing down on the rooftops of the River Rouge complex and the Chrysler tank arsenal and the Fisher Body plant on Van Dyke Avenue. But that summer, what was happening inside those buildings had no peacetime equivalent. Shifts ran around the clock. Workers arrived at 4 in the morning and left at noon. The next crew came in as the first was still walking out. The parking lots never fully emptied. Inside, the noise was constant, the clang of hull plates being welded, the shriek of machine tools cutting steel, the thud of press components dropping onto assembly lines that had been modified, extended, and reconfigured to move faster than the men who designed them had thought possible. The Army Ordnance Department had a target. Germany had an assumption. Those two things, moving on a collision course through the middle years of the war, would decide the outcome of the campaign in Northwest Europe before a single round had been fired in Normandy. What no German planner ever fully calculated, and what the archival record now makes plain, is that by the time the first Sherman rolled off a landing craft onto a Normandy beach, the factories producing it had already settled the strategic argument. The battle was already decided on the floor of a plant in Michigan. Germany never had a mechanism to close the distance, and the evidence that proves it has been sitting in the archives in Washington and Dearborn for 8 decades, waiting for anyone willing to read the production logs and do the arithmetic. If this story is pulling you in, take a second to hit the like button and subscribe, and drop a comment telling me where in the world you're watching from. It means a great deal to know who's listening, to understand what was being built in those plants, and why it mattered in a way that German planners never fully grasped. The record has to begin not in Michigan, but in North Africa, in the spring of 1943, in the wreckage of an American armored offensive that had gone badly wrong. The Kasserine Pass engagement in February of that year had put the M4 Sherman against German armor in a way that revealed, with brutal clarity, the limits of what the United States had sent to war. The Sherman was a reliable vehicle. It started in cold weather. Its radial engine was well understood by mechanics. Its crew could be trained quickly. The Army had designed it to be produced in large numbers, and it had succeeded at that. By the time American units arrived in Tunisia, the M4 had been coming off assembly lines for over a year and was present in the theater in substantial quantities. None of that changed what happened when it met German armor at close range, or when anti-tank guns found the upper hull from the flanks. The armor was not thick enough at the sides. The gun, a 75mm weapon adequate against earlier German vehicles, was struggling against the latest variants. The after-action reports from Tunisia were explicit. The Ordnance Department read them. They contained a specific problem. The Sherman was being destroyed faster than the tactical situation could absorb, not in every engagement, and not because the crews lacked skill, but because the balance of firepower and protection had shifted since the tank had been designed. The Ordnance Department did not need to be told twice. What the Army required, and what the factories were already beginning to prepare, was not a replacement for the Sherman, but a supplement to it, a vehicle that could engage the heavier German armor appearing in Tunisia and, everyone understood, in whatever theater came next. That vehicle was the M26 Pershing, but the Pershing was years away from series production. In the interim, something had to bridge the gap. That something was the M4A3, a revised Sherman with a Ford JA liquid-cooled V8 engine producing 500 horsepower, and alongside it, the eventual upgunning of the hull to accept a 76mm gun capable of penetrating German armor at combat ranges the 75 could not reach. But neither of those decisions, by themselves, explains what Germany failed to understand. What Germany failed to understand was the number. What the record shows, drawn from the War Production Board reports filed between 1942 and 1945 and deposited in the National Archives, is a production curve that German intelligence never accurately modeled. In 1942, American tank plants produced approximately 24,000 tanks. In 1943, that figure rose to 37,000. In 1944, it approached 18,000 M4 variants alone, not counting the light tanks, the tank destroyers, the self-propelled guns, the armored personnel carriers, and the half-tracks moving down adjacent lines in the same facilities. The German tank industry, by contrast, produced approximately 6,000 Panzers in 1943 and approximately 9,000 in 1944, a figure that included the Panzer IV, the Panther, and the Tiger combined, across all fronts, against every enemy Germany faced simultaneously. The arithmetic was not subtle. It was not a marginal advantage. It was a structural condition of the war that the Wehrmacht's armored arm had no mechanism to overcome, no matter how capable its individual vehicles were, no matter how well its crews had been trained. The Chrysler Jefferson Avenue plant in Detroit is the most documented node in this story. The plant had been converted from automobile production in 1941 under a contract with the Army Ordnance Department, and by 1943 it was producing M4 hulls at a rate that the plant managers themselves described, in internal correspondence, as operating at the margin of physical possibility. The plant floor covered several 100,000 square feet. The assembly line had been reconfigured twice since the first tanks rolled out, each reconfiguration aimed at reducing the time between when a hull arrived from the press shop and when a completed vehicle drove out the far end of the building. The workers on the line, machinists, welders, inspectors, assembly hands, were operating under a piece rate system modified for wartime contracts. Overtime was universal. Absenteeism was tracked daily by supervisors who reported figures upward to plant management, because a gap on the line was a gap in production, and a gap in production was a number that would eventually appear on an Army officer's desk somewhere downstream. What the plant's surviving production logs show, now held at the Benson Ford Research Center in Dearborn, is a month-by-month output that increased not incrementally, but in structured steps, each step corresponding to a line modification, a tool change, a process improvement worked out on the floor by the men running the machines rather than by engineers at a drawing board. The welders on the hull line had developed a jig system for holding the front glacis plate at the correct angle while the weld was laid down. The original procedure required 2 workers to hold the plate while a third welded. The jig eliminated one of those positions and reduced the cycle time per hull by a measurable fraction. Multiplied across hundreds of hulls a month, that fraction became a shift's worth of production. These are not large numbers in isolation, but they accumulated shift by shift across every plant in the production network, and the accumulation is what the German intelligence system never computed accurately. The Germans, whose tank production was centered on facilities in the Ruhr, at Kassel, at Nuremberg, operated under a different set of constraints entirely. The German armored industry had not been converted from consumer production at the scale the American industry had. It had been built on specialist manufacturing traditions, precision engineering, craft-oriented assembly, an emphasis on complexity and quality that produced vehicles of formidable individual capability, but at rates the war's appetite could not satisfy. The Panther, which entered production at the Mann facility in Nuremberg in 1943, was a superior tank in several technical respects. Its frontal armor, angled at 55 degrees from vertical, was effectively impenetrable to the Sherman's 75mm gun at most combat ranges. Its 7.5cm KWK 42 gun could destroy a Sherman from over 1,000 meters. It was faster than the Tiger and more mechanically reliable than the early production variants of its own type, which had suffered serious breakdowns during the Kursk offensive in the summer of 1943. German crews who had trained on the Panther and learned its characteristics in combat trusted the vehicle. But the Panther was difficult to build. The Maybach HL-230 engine that powered it required precise manufacture of components that were sensitive to quality variation. The rear deck, the cooling system, the final drive assembly. These were areas where production shortcuts that might pass inspection showed their consequences in the field. At Kursk, a significant number of Panthers were lost, not to enemy fire, but to mechanical failure before they reached the line of departure. The production figure for Panthers across all of 1943 was approximately 1,800 vehicles. In the same period, the Chrysler Jefferson plant alone was producing Shermans at a rate that, annualized, exceeded that figure. That imbalance sits at the center of the record, and it was invisible to every operational assessment the German Armored Command produced throughout the war. The record also shows something that is easy to miss if the lens stays fixed on the front lines. The American production system was not just building tanks in large numbers. It was building them in a way that preserved options. When the Ordnance Department decided in the autumn of 1943 that the standard M4 needed a more powerful gun, the modification path was already prepared. The 76mm gun had been developed in parallel with the up gun turret that would house it, and the hull dimensions of the M4A3 had been designed with enough internal volume to accept the change without a fundamental redesign of the vehicle. The factories absorbed that modification in stride. A plant that was producing the 75mm arm variant in October was producing the 76mm arm variant by the following spring, on the same line, with retrained workers and modified tooling, without a gap in output that would have shown up as a lost month in the production record. Germany faced a different problem when its engineers identified the need for improvements to the Panther. The final drive assembly, which had proven brittle in early production vehicles, required a redesign that had to flow back through the supply chain to the subcontractors producing the components, to the assembly workers fitting them, to the quality control procedures checking the result. Each of those steps took time, and the time came out of production. The German system could improve its vehicles. It could not improve them at the pace the American system was improving its own while simultaneously maintaining output volume. What the Army Ordnance Department understood, and what is documented in the modification orders and production records now held in the National Archives, is that the Sherman was never intended to be the final answer to the German armored problem. It was intended to be the answer that could be delivered in large enough quantities, reliably enough, to hold the field while the final answer was being developed and produced. The M26 Pershing, when it arrived in small numbers in February of 1945, confirmed the design logic that had been running underneath the entire Sherman production program. Here was a vehicle with frontal armor thick enough to resist the Panther's gun at most combat ranges, and its own 90mm gun capable of defeating the Panther frontally at distances where the Sherman's 76mm was still marginal. The Pershing was what the Army had wanted since Kasserine. The Sherman was what had held the line while the Pershing was being built. That holding action, fought on factory floors in Michigan and Ohio and Pennsylvania, is the part of the story the production records preserve and the battlefield dispatches do not. If this is the kind of history you want more of, subscribe and turn on notifications. There's far more in the record still to cover. Your support is what keeps these stories coming. The Fisher Body division of General Motors operated the Grand Blanc tank plant near Flint, Michigan. It had been purpose-built for tank production in 1942 on a site that had been farmland 2 years before. The plant was, by the end of 1943, the largest tank production facility in the world by output. The production floor was designed around the M4A3, and the layout had been engineered from the beginning to allow modification without shutting down the line. When the Army Ordnance Department issued a change order, a new vision port configuration, a modified ammunition stowage arrangement, the wet stowage system for propellant that reduced the Sherman's catastrophic fire risk when the hull was penetrated, Grand Blanc could absorb the change in a matter of weeks rather than months. The workers who implemented those changes were not engineers in the formal sense. They were pattern makers, tool and die men, experienced hands who had spent careers in the General Motors body plants before the war and who understood the production system from the floor up. When a change order arrived, it was the foreman and his senior machinists who worked out how to integrate the new specification into the moving line without stopping the vehicles behind it. There are production reports from Grand Blanc in the National Archives that record not only the number of tanks completed, but the number of tanks that failed their pre-delivery inspection and were cycled back for correction. The rejection rate in the first months of the plant's operation was higher than the Army wanted. By late 1943, after the inspection procedures had been refined and the most common failure points identified and addressed at the manufacturing stage rather than the inspection stage, that rate had dropped significantly. What came off the line was a vehicle that worked. Not a perfect vehicle, and not a vehicle that could defeat a Tiger in a frontal engagement at long range. That was never the claim. What it was a vehicle that could be delivered to a unit, fueled, armed, and driven into action, and would continue to function in the way its crew expected it to function. That reliability was itself a weapon, though it was not the kind of weapon that appeared in technical specifications or capability assessments. It appeared in operational availability rates, in the percentage of vehicles in a formation that were running and ready when the orders came down to move. A formation of Shermans that had taken losses in a day's fighting could receive replacement vehicles within days. The replacement vehicles arrived with standardized parts, the same engine components that the unit's mechanics already knew, the same track connectors, the same gun mounts. A crew that had lost their tank in the morning could be back in action in a replacement vehicle by the following day. German formations that lost Panthers in combat faced a different arithmetic. Replacement vehicles had to come forward from depots that were operating under sustained Allied air attack from 1943 onward. Spare parts for the Panther were not standardized to the same degree as American components, and the mechanical complexity of the vehicle meant that field repairs that an American unit could perform with the tools on the tank retriever sometimes required a specialist's intervention. The Wehrmacht's maintenance system was skilled and resourceful, but it was working against a production and logistics gap that skill alone could not close. The German High Command understood, in broad terms, that American industrial output exceeded German output. That understanding appears in the records, in captured documents, in the post-war testimony of senior German officers, in the operational planning assessments that the Wehrmacht's Armored Inspectorate produced through the middle years of the war. What those documents show, however, is that the German appreciation of American production capacity consistently underestimated the actual figures. In some cases, German intelligence estimated American monthly tank output at figures that were 40 to 60% below the number actually coming off the lines. The reasons for that underestimate were structural. German intelligence had limited visibility into the American production system. The conversion of automotive plants to tank manufacture was not announced in detail. The expansion of existing facilities, the additional press shops, the new foundries, the extended lines, happened inside buildings that had already been on the map for years. From the outside, the Grand Blanc plant looked approximately as large as it had been when it was built. What had changed was what happened on the inside, and that change did not show up in aerial photography with any precision. What reconnaissance aircraft could document, when they could reach American targets at all, was the physical footprint of a building. What they could not document was the shift system, the line speed, the modification cycle, the rate at which a design change flowed from an Ordnance Department engineer's desk to a completed vehicle rolling off the end of the assembly line. That process, invisible to aerial photography and incompletely understood by the analysts trying to model American output, was the real mechanism of the advantage. It was not a single decision or a single technology. It was a system, a way of organizing production, absorbing change, training workers, inspecting output, and moving finished vehicles to ports and onto ships that had no equivalent in the German industrial system, and that Germany had not developed the institutional capacity to replicate, even if the raw materials had been available. By the spring of 1944, the assembly lines in Michigan and Ohio and Pennsylvania had been running at high capacity for 2 years. The workers on those lines had become efficient in ways that resisted easy description. A welder who had laid down the same joint on the same hull plate for 18 months was not working from procedure any longer. The procedure had become physical memory, the angle of the torch, the speed of the pass, the way the puddle behaved when the steel was at the right temperature. The inspectors who walked the line knew which stations were prone to which defects. The foreman knew which workers could be moved to a new station without a break in productivity, and which ones needed time to calibrate. This accumulated knowledge, invisible in any production record, was part of what kept the lines moving and the rejection rates low. The German factories producing Panthers and Tigers were also staffed by skilled workers. But the German system was under pressures the American system did not face. Allied bombing of the Ruhr and of the transportation network feeding the tank factories was intensifying through the spring and summer of 1944. The disruption was not always catastrophic in a single raid, but it was cumulative. A plant that lost its coal supply for 3 days because a marshalling yard had been bombed did not simply resume at full production when the coal arrived. There were resequencing costs, inventory gaps, schedule compressions that rippled forward through the production schedule for weeks. The German production system was resilient. It absorbed those disruptions and continued to function, but it was absorbing them while simultaneously being asked to increase output to meet combat losses that were themselves accelerating on 2 fronts. That equation had no solution the German industrial system could provide. There is a detail in the production calendar that makes this plain. In the period between June of 1944 and the end of that year, American factories delivered to the European theater enough replacement Shermans to re-equip every armored division that had landed at Normandy from scratch, twice over. The vehicles lost in the hedgerow fighting of July and the Falaise engagements of August and the Siegfried Line assaults of September were absorbed by the replacement pipeline, without a single American armor division being stood down for lack of equipment. The German armor divisions that fought those same actions, the 2nd Panzer, the 12th SS, the Panzerlehr, were reduced by the end of 1944 to fractions of their authorized strength, not because their tanks were less capable vehicle for vehicle, but because the pipeline that should have replenished them did not exist at the required volume. The Normandy landings in June of 1944 put the accumulated American output into the field in numbers that the German army had not planned against. The armored formations crossing the beach had Shermans. The follow-on formations had more Shermans. The supply chain behind them had spare engines, replacement track, gun barrels, and transmission components sized for Shermans. When a Sherman was knocked out, the logistics system built to support it could replace it faster than the German armored formations opposing it could absorb replacements of their own. That asymmetry was not visible in a single engagement. It was visible in the campaign as a whole, in the rate at which American armored strength held steady or recovered from losses, and in the rate at which German armored strength in the West declined, steadily, week by week, toward the point where whole divisions were operating with a fraction of their authorized vehicle strength. The workers in Grand Blanc and at the Chrysler Jefferson plant did not know the operational consequences of what they were building. They knew their shift, their station, their production quota, and the people working beside them. A welder on the hull line did not see Normandy. He saw steel plate and the joint he had to make before the carrier moved the hull forward. What he could not see, and what German planners could not accurately model, was the aggregate of 1 million such joints made by a workforce that had organized itself across 2 years into something the war had never encountered before, an industrial system capable of outproducing any damage done to it faster than the damage could be inflicted. The record that survived, the War Production Board reports, the plant production logs at the Benson Ford Research Center, the Army Ordnance Department files, and the National Archives at College Park, preserves the numbers without the noise. The numbers are the argument. In 1944, the United States produced more armored vehicles than Germany had produced across all the years of the war combined on both the Eastern and Western fronts. Some of those vehicles were destroyed the day they arrived in theater. Some were lost in the hedgerows of Normandy in the weeks after the landing. Some were knocked out by Panthers and Tigers at ranges where the Sherman's armor gave no protection. What the production numbers show is that none of that mattered at the strategic level in the way it mattered tactically. The German army could destroy Shermans. It could not destroy the rate at which Shermans appeared. That distinction between winning engagements and winning the campaign is what the workers at Grand Blanc were deciding, one hull at a time, in a building that most of them had never left the state to reach. The plants continued to run until the war in Europe ended in May of 1945. After the German surrender, production wound down in stages. Some plants converted back to automobile manufacture within months. The Grand Blanc facility shifted to civilian production and eventually closed decades later. The men and women who had worked the lines went back to the lives the war had interrupted, and most of them never spoke at length about what they had done because there was nothing dramatic to describe. They had shown up. They had done the work. They had gone home. What remained was the record, the production logs, the inspection reports, the modification orders, the shift schedules filed into boxes that eventually traveled to archives in Michigan and Washington. Those documents are accessible today to any researcher who requests them. The numbers in them are not classified. They were never secret in the way that tactical plans are secret. They were simply the administrative record of what had been built, and when, and by whom. A Sherman M4A3E8, the late war variant with the horizontal volute spring suspension and the 76mm gun, stands today at the National Armor and Cavalry Museum at Fort Moore in Georgia. The vehicle on the display floor is not a replica. It is a surviving example of the type that came off the Michigan assembly lines in the final year of the war. The production line's answer, in steel and welded seam and machine component, to a strategic problem that the workers who built it never saw directly, but contributed to resolving as completely as anyone who carried a weapon across the fields of northern France. Germany knew, in general terms, that American output exceeded German output. What Germany did not know, what the record shows they systematically underestimated, was by how much and how fast the gap was growing, and how little the loss of any individual vehicle in any individual engagement affected the rate at which the next one would arrive. That was the thing the factory floor understood without articulating it, and the German high command never fully calculated. Every hull that passed inspection and moved to the delivery lot was one more unit of that rate, one more number in a column that Germany had no answer for. The war did not end at Normandy, or at the Siegfried Line, or at the Rhine crossing. It ended, in part, in a building in Michigan in 1942, when the first welding jig was fitted and the first hull moved forward on a line that would not stop for 3 years. Germany never knew how fast that line was moving. By the time the evidence arrived on the battlefield, it was arriving in the form of steel. Thank you for staying with this until the end. If what you heard here stayed with you, the other films on your screen carry the story forward. Subscribe if you haven't, and I'll see you in the next one.